I want you to draw out your nephron, and I want you to draw out what is reabsorbed to your nephron, and I want you to draw out what is reabsorbed at each step, right? So the first thing that you need to do, and if we were in lab, I would cover this again, but you can go back and listen. Nephron. I want you to know what's reabsorbed where for lecture, what's kicked out, right? How do we regulate, glucose? How do we, the whole aldosterone pathway, ADH, urine output, et cetera, dehydration. But for lab, what we would have done is we would have predicted what would happen when you drink different solutions. So we would have covered the solutions, right? And then the urine output, the specific gravity. Whoops, sorry guys. pH. I guess I could have made this bigger. Let me make this bigger, guys, sorry. I want you to look at the review sheet. So you need to spend a lot of time understanding this because this is not something that's going to come easy. Oops, I want to draw. There we go. Okay, so let's try this again. So solution. Then, let's see, urine output. So urine output, specific gravity, pH. What else am I missing, you guys? Urine output, specific gravity, pH, glucose. So should we see glucose? Protein. Okay, so let's go through and figure out our predictions for this. So solution one would be no treatment, right? So we would have somebody who did no treatment. What would urine output be? So normal urine output, this is where you need to look up normal ranges. So normal urine output would be, let's say 100 mils, right? Usually about 10 to 100 mils an hour. Specific gravity, normal specific gravity is 1.010 units of gravity. pH, let's say pH 6, there should be no glucose, no protein. What if someone drank 500 mils of water? 500 mils of water. So they drank 500 mils of water. Let's say they're already hydrated. What would happen to urine output? Urine output would increase, okay, because they're already hydrated, so they are dumping water in the urine. What would happen to specific gravity? Specific gravity would drop, so that means it would get closer to 1.000, which is 1.001. Is water going to affect the pH? Nope. Should you see glucose in the urine? Nope. Protein? Nope. Okay. Then somebody is going to drink, another person would have drank 500 mils of sugar water. So let's do glucose plus water. Okay, so you're still drinking water, so urine output's going to increase. Specific gravity is going to drop. pH is going to stay the same. If we drink glucose, should we expect glucose in the urine? No. Okay. Just because we drink glucose, our body should process it. So we would release insulin and pull glucose into the cells. No protein. Okay. What about 500 mils of, in lab, it would have been sodium bicarbonate. So it would have been 500 mils of sodium bicarbonate, or baking soda water, which is really gross. It kind of tastes like Alka-Seltzer. Let's separate them though. So let's look at sodium water, right? So if we have more salt, what's going to happen to blood? blood particle concentration or osmolarity is going to increase. And so we're going to hold on to water. So urine output's going to drop. And because we're peeing out less water, same amount of particles, specific gravity is going to go up. Are we screwing with pH? No, we're not. Oops, so it's going to stay 6. Should we see glucose in the urine? No. Proteins? No. What about, can you give me ADH levels? So if we did excess sodium in the bloodstream, what would happen to ADH? More particles, increase in ADH. Good. 500 mils, we could do this all day, of so HCO3 water. Whoops. Okay. So we're drinking bicarbonate water. So technically, if we drink bicarbonate water, it's still water, and it's not going to dehydrate you, so your output should go up. Specific gravity, they're inversely related, so it's going to drop. Now here's a trick. If we have bicarbonate is a pH of about 7 to 8. Okay. So your blood pH is going to be high, right? Your blood pH is going to be 8. And so you're going to hold on to protons instead of secreting them. So you're going to hold on to protons instead of secreting them. And so if you're not peeing out the protons, what's going to happen to pH of urine? It's going to jump up. Okay. No glucose, no protein. Am I forgetting something? I don't think so. I think that would be it. What happened if your blood pressure was really low? So let's say, let's do low blood volume. So you have a drop in blood pressure. So what would happen? Okay, so you would release aldosterone. So ALD would be high, right? So would you pee out water or would you hold on to it? Good, you're going to hold on to it, so urine output drops. Specific gravity is going to go up. Does this affect pH? Nope. Glucose? No. Protein? No. Okay, good. If urine output is less, what is the color of that urine? Good, it's probably dark yellow. What about if we have diabetes mellitus? So diabetes mellitus, you're going to pee out glucose in the urine. So, and because you have glucose in the urine, that is going to pull water towards it. It acts as an osmotic diuretic. If you read your lab, it tells you that. So urine output's going to go up. Specific gravity is going to drop. It's actually going to dehydrate you because you're pulling water from the blood into the urine. It doesn't screw up pH. Depending on how damaged your kidneys are, you may or may not dump out protein. What if you are starving? What we're interested in is, did you dump out proteins? Did you, like under stress, like if I was severely dehydrated, if I was starving, if I was extreme exercising, I'm going to dump out proteins, and you may even see albumins. Okay, so that gives you an idea. All right, I want you to spend some time going through the lab. It's really not fun that we didn't get to do this all together as a class and analyze our urine together, but it's really important to be able to look at urine and understand what's going on in the blood of that patient. So if the urine is dark yellow, you know that they're dehydrated, okay? They are releasing antidiuretic hormone. If they're severely dehydrated, they're releasing aldosterone after that. If they're releasing aldosterone, what is blood pressure like, right? Blood pressure is really low. And so when you took a patient's blood pressure, it'd be really low. And because it's really low, your heart rate and stroke volume or your cardiac output is trying to compensate for that. So heart rate will be really high. Okay, so if somebody's severely dehydrated, blood pressure drops, heart rate's high, you know that they're trying to pull in water. And so you would give them IV fluids, right? Okay, guys. So go do the lab now and write it out, analyze it, look up normal values, understand how the hormones affect urine output, and regulate homeostasis. Great job, you guys. Great semester. And email me if you have any questions. I'm so happy for you. Yay! Give yourself a pat on the back. Last lecture of the semester. Woohoo!